The next important feature that is provided by SQL is joins, and it is used a lot in SQL statements. So if you are or if you are going to use SQL in your day-to-day work, there's a 99.99% chance that you'd be using joins. Now let me first paint a picture of what a join is. Join is used to join two or more tables. So what is that join? So let's say I have this orders table and there are only three columns: order ID, customer ID, price, and there are four rows: order ID 1, 2, 3, 10, and this is the customer ID and this is the price. Then we have customers table, and in customers table also I have three columns: customer ID, address, email, and four rows with these values. I have already told you about relations. So this orders table is related to the customers table, and the relation is done via a common link, which is the customer ID. So customer ID is used to relate these two tables, the customers table and the orders table. Let's say if someone wants to find out the customer detail of a particular order, what you have to do is that you'll have to get the order ID first. First, you'll have to get the order and then the customer ID from the order, and take that customer ID and go to the customer table and get customer details. So let's say I want to find out the customer details of order ID 3. So I know that the customer ID is 10044. So now if I go to the customer table, I already have 10044. So I know that this is the customer. That customer resides in Mumbai and B is the email ID of that customer. So this is how we do it. But there are other ways to do it also, which is join. And when we perform join, we use this particular link to join two tables. By the way, the data here is not correct because as you can see, customers is the parent table and orders is the child table. So I have some customer IDs in the orders table which are not there in the customers table. So PostgreSQL or any database for that matter will not allow me to insert these rows because the customer ID is not present. So now if I have to find out the details of customers for a particular order, as I said, one way is to get the customer ID first and then get the customer details from customers table. This is fine for small number of rows. So what if you have millions of rows? It does not make sense. That's why joins are used. What joins do, they join two tables based on a common link, and the common link is the primary key and the foreign key. Typically you can use customer ID of the orders table and customer ID of the customers table to join these two. You can use other columns also if you have the same column available, and if those columns do not fall under foreign key and primary key, that is also fine. It's not necessary that you'll have to join using customer ID only. So let's say these two are independent tables. There is no reference or there is no relation between the two tables. I have not created any foreign key constraint in orders table where customer ID is referencing the customer ID of customers table. So if I don't do that, then these two tables are isolated tables. They are not related. But even then, I can join these two tables based on customer ID. So it does not mean that we need to have primary key and foreign key to join tables. We can use non-primary key columns, non-foreign key columns also to join multiple tables. There are three types of joins. The first one is inner join. So what happens in inner join? So this is how we write the select statement. So let's say select O dot order ID, O dot customer ID, O dot price, C dot address, and C dot email. So what are these O dot and C dot? You might already know these are the aliases of two tables. Now why do you want to put alias? Because we do not want to mention the entire table name. So if you do not mention alias, then you'll have to mention orders.order ID, orders.customer ID, orders.price, customers.address, customers.email. So that's why we use aliases. So after select, we have from orders followed by O, this is the alias of orders. And then we use something called inner join and then followed by customers, the second table. And we can join more tables also. We can join three tables also using inner join, which we'll see in the hands-on. But here, what am I doing? I am joining these two tables, orders and customers, using inner join. Now, the second thing is that how do you do the join? We do the join using columns. So we are saying do the join on O dot customer ID, which is customer ID of orders table, equal to C dot customer ID, which is customer ID of customers table. Now it should not be cust ID actually, it should be customer ID. My bad, but that's fine. So now the question is what rows would be returned. So I'm joining these two tables and I'm saying that return the rows from orders table and customers table by inner joining them based on customer ID. So whenever the value of customer ID matches in the two tables, it will be returned. So let's go ahead and see how SQL will do that. So first we'll go to row number 1. So the customer ID is 10001 and price is 10. Here also we have customer ID equal, we have a customer ID with 10001 and then we have address. So this columns from the first rows of these two tables would be returned. Then it will check whether there are other customer IDs or not. So 10001 is not there anymore. So it will go to the next one, which is 10010, and that is not there. So it will not return. 10044 is also there. So the columns of row number 3 in orders table and row number 2 of customers table will be returned. Then it will check whether 1004 are there anymore or not. It's not there. So what would happen is it will go to the next row, row number 10, 10022. It will check that it will not there. As the customer is not there in the customer table, so this row will not be returned. So only 1001 and 10044 would be returned because we are using customer ID in the join column and the common rows will only be returned. So that's what inner join is, and this is how the output would be. So you will have order ID, customer ID, price, address, email, and the order ID is 13, customer ID is 1001 and 10044, and then I have price and address, right? So these are the rows that would be returned. So the common rows or the rows which are there in both the tables based on the joining column will be returned. That's what inner join is. Let's look at some hands-on. For all the joins, I'll be using the small data set. So what I have done is I have truncated the table customers. So this is the command, truncate table customers followed by the cascade keyword, because there's a relation between orders and customers. Orders table references the customers table. So if you do not mention the cascade keyword, you'll get some error. Similarly, I have truncated the sellers table by cascade and I have truncated the orders table, and I did not have to mention cascade here, by the way. Then what I did was I have this particular table orders and there are two foreign key constraints, there are two referential integrities, right? So I dropped these constraints. So I executed this command, alter table orders drop constraint followed by the name of the constraint. So I have removed this particular referential integrity, which defines the relationship between customer and orders. Then I have also dropped the referential integrity or the constraint orders underscore seller underscore fk, and this is the constraint, and this constraint has also been deleted, which defines the relationship between orders table and sellers table. The reason I have done it because otherwise I'll not be able to insert rows in the orders table which are not there in the customers and sellers table. So now I'll load these tables with the small data set. Let me go ahead and load it and then I'll show you the inner join. I have done is that I have loaded the tables customers, sellers and orders using the small files. I'll not be using the large file this time. And these are the commands. I'm using the function table import from S3 after setting the search path. So now if I do a count star from all these tables, as you can see, customer table has only 8 rows, sellers table has 12 rows and orders table has 100 rows. Now what will I do is, let me take a look at the structure of orders table. So we can type this /d plus orders and this is the structure. Similarly, let me take a look at the structure of customers table. And this is the structure of customer table. So as we already know that customer ID is the one based on which we'll perform the join. So let me run the inner join query. So select, I'll use an alias named O. I want to get the order ID, then the customer ID from orders table, not customer table, and the order date. And from customer table, I want to get the email and phone. That's it. And now I'll be fetching this record from orders table. So let me alias it as O, comma, customers table, and I'll alias it as C. Now comma will not work here like other SQL statements. So I'll have to mention inner join. So if I mention inner join, what is happening? Orders table is getting inner joined with customers table. And based on what? Based on the customer ID. So if I mention O dot customer ID and C dot customer underscore ID. So now it would return, I think, all the rows. Okay, 71 rows have been returned, not all the 100 rows, only the rows which are matching. So only the rows where the customer ID is matching across these two tables, only those rows have been retrieved. So that is what inner join is. And I will execute left outer join, right outer join and full join on these tables. Now let's proceed with the next join, which is called left outer join or left join. As we are talking about left join, that means one of the tables should be left and the other tables should be right. And let's say this table is left and this table is right. There's a way to mention and there's a way to know which table is left and which table is right in the SQL statement. So now what am I going to do is that I'll be joining these two tables. Again, the joining is or will be based on the customer ID because that is the column, a common column. It does not necessarily mean that it has to be primary key and foreign key. Any common column would do. So now what would happen? Again, the select statement is same. As you can see, it is exactly same. From orders aliased by O and customers is aliased by C. And I'm joining on customer ID. And it should be customer ID, not cust ID. But instead of inner join, I'll mention left join here. As I have mentioned left join here, and I have orders table here and customers table here. The table on the left of left join is the left table, and the table on the right of the left join keyword is the right table. Meaning in this case, orders table is the left table and customers table is the right table. But if I mention customers first and then orders, if customers had been here and orders had been here, then customers would have been the left table and orders would have been the right table. So that matters a lot because that changes the output of the query. Now, what would happen here is it will, of course, find the common rows like 1001 customer ID and 10044, but it would also output all the rows from the left table, even though they do not have any matching. Meaning, it will output all the rows from orders table because this is the left table. So this is how the output would be. I'll have all the rows from orders table and I'll have only two rows from customers table, and these two rows are the matching rows on customer ID. For the remaining rows which are not matching, the value from customer table will have null. For example, address and email would have null values in it. So I'll run the exact same statement, but instead of inner join, I'll mention left join. So left join and left outer join are same. So now if I execute this, I am seeing 100 rows. Last time it was only 71 rows based on inner join. And as you can see, some of them has blank values, meaning these rows in the order table does not have any value in the customer table. So that's what inner join is. And it is only possible because I have removed the referential integrity. If I create the primary key and foreign key, then this customer ID should have been there in the customer table. Otherwise, I would not have been able to load the orders table. So that's why I removed it to show you left join, right join, etc. But now, as I said, I am seeing the output of the row from the left table, which is the orders table, which are not there in customer. Now, if I change the position, let's say I mention customers here and I mention orders here. Now, customers would become the left table and orders would become the right table. So now we can see again only 71 rows because all the rows in orders table are there in the customer table also. So that's what it is showing. It is similar to inner join, but let me do something. Let me insert some rows in the customer table. So let me do a select star from customers, and I think there are the number of rows are very less. So what will I do is I will insert at least two rows in the customer table, and those two rows should not be there in the orders table. Let me run the insert and come back to you. So I have inserted two rows, 99228 and 99229 in customers table, and I know that these rows are not there in the orders table. So there are no rows in the orders table which has customer ID as these two. And now let me go ahead and run the same, run the same query. Now I should be able to see the customers here. So if you see, these are the two rows for which order ID is not there. Now why I'm seeing these rows? Because what I did is I have put customers on the left hand side of the left join and orders in the right hand side of the left join. So similarly, we have right outer join or right join. So what would happen? It's an opposite of left join. So we have the same select statement, and instead of inner join and left join, we'll mention right join. So in this case, this customer table would become the right join because that is on the right of this particular keyword, right join, and the output would be like this. Now it is similar to left join by putting customers here and orders here. It is exactly same. And if I run the query that I had just shown you in the left join, and instead of left join I mentioned right join, we'll see the same output. So what am I doing here is this is the query. I'll remove customers from here and I'll put orders, and instead of left join I'll mention right join, which basically selects the rows, the common rows from both the tables and the additional rows from the right table. And for left join, it selects common rows from both the table and additional rows from the left table. So these are the main joins, and apart from this, we have something called full outer join or full join also. As you already know, we'll have to change it to full join. Now, what would happen? It would return all the rows from orders table and all the rows from customers table, and the matching rows would only come once, and the non-matching rows will have null values in it. So the output would be similar to this. So for 1 2 3 10, for 1 I'll see the value of customer, for 2 the value of customer would be null, for 3 I'll see all the values, for 10 the values would be null in case of customers, and for the other one the values would be null for orders. So this is a full join. I'll have to change the right join to full join, that's all. And this is the output. As you can see, I do not have customers here. So these are blank, and these are the matching rows where I can see all the values. And at the end, I should be able to see the columns which are not there in orders. So it's a mix of both left join and right join. So I can see the common rows. I can see all the rows from the left table, and I can see all the rows from the right table also. So this is what full join is. And this concludes the joins. Please go ahead and practice it, and it is very important because we'll be using joins a lot. And if you want to work as a data engineer, SQL is something that you should definitely know. Not only data engineer, if you want to work as a data scientist or data analyst or database administrator, machine learning engineer, you need to know SQL. So, and join is one of the very important topics in SQL.